And Descartes says this, his rule of signs say the number of positive real roots, zeros, or solutions, these are all synonymous, of a polynomial is equal to the number of sign changes in the polynomial, or less by a factor of 2. So we'll do the positive one first. So the number of positive real solutions is equal to the number of sign changes in P of x or less by a factor of 2. Okay? So look at P of x. Do I start out with a positive or a negative? Positive. Does it switch? Yeah. Does it switch again? Yep. Does it switch again? So it switches 3 times. So therefore, the number of positive real solutions is going to be 3. Or less by a factor of 2. So we subtract 2. Or 4, or 6, or 8, until we get to a number low enough so we get down to 1 or 0. Right, I go from positive to negative, so this is a switch there. That's my first one. This is my second switch, and this is my third switch in signs. Okay. Now, the reason why there's either 3 or 1 is there's 3 positive real solutions, or there's 1 positive real solution and 2 imaginary. You see that? Because we don't know how many imaginary there are for sure yet. So that's why we say either 3 or 1, because imaginary numbers come in pairs. Okay, the second part. The number of negative real zeros, roots, or solutions of P of x is equal to the number of sign changes in P of negative x, or less by a factor of 2. So in order to compute the number of negative real roots, we have to list what P of negative x is. If I plug a negative x, what is that going to become? Then when you square the negative just goes away, right? So you're able to keep that subtraction sign. Then, okay, how many sign changes are there? Starts out negative. Does it ever switch from being negative? Never switches from being negative. We're not looking at how it switches from the original. We're looking at the sign changes in P of negative x. And there are none. So therefore, we know the number of total real solutions. Three or one. Because it's either going to be 3 and 0 or 1 and 0. Okay? That'll be the number of real solutions we have. Okay. P of x equals negative x to the fourth minus x squared minus 1. So positive, positive real. How many sign changes do you see? 0. So there are no positive real roots. How do I compute negative real? Well, I get negative x. And I do P of negative x is going to be equal to. Did anything change? Nope, it didn't. And so as I look at this, I have no sign changes in P of negative x. So how many negative real? 0. So how many total real do I have? There are none. There are none. Does that make sense? What does that mean if there is no real solutions? Doesn't ever cross the x-axis. It's always below. Okay, it's always below. Is it possible to draw a function that does not cross the x-axis? We got one right there, don't we? Suppose this was to the 5th power. Is it possible to draw a 5th degree that does not cross the x-axis? No, I mean, you might try. You might be like, okay, I got an n going up. I'm going to start down. I'm going to... There we go. All right. Okay, you see that just does not work. Okay. All right. Yeah, that is voodoo math. Thank you very much. Okay. All right. So that you will use a lot. DesCartes' rule of signs you'll be expected to use on the test. The upper and lower bounds, you're not going to be expected to use that in the same way. This is much, much less critical. It's just kind of a nice side note. We're going to take 3 minutes here and talk about it. It's no big deal. Watch. The upper and lower bounds theorem says this. Suppose I had a polynomial, x to the 5th minus 4x, you don't have to write this down, plus 2x squared minus 3x plus 48, okay? 48, oh wow, there's lots of choices there, aren't there? Wow, that would be a pain in the butt, wouldn't it? And as you look here, I start out at positive 48, and I go all the way down to negative 48. There's a lot of choices in the middle there, right? Wouldn't you like to narrow this list? Like, what if you knew all of your results sat within there, where this was an upper bound and this was a lower bound? Wouldn't that be nice? That would be extremely convenient. Well, the upper and lower bound theorems say this. If b is positive and you divide it into the polynomial and you come up with all non-negative results, come up with all non-negative results, and 0 is non-negative, okay, then b is an upper bound. So all I'm going to ask you to do to show that for your assignment today is this. We're going to show that this polynomial has zeros that lie between -3 and 2. That would mean this is an upper bound and this is a lower bound. Okay, the positive is going to be an upper bound, the negative is going to be a lower bound. So if I plug in 2 and I go, let's see, we got 1, 0, -3, 2, and -5. What do I do first? Drop the 1 in, multiply, then add. And I do that over and over again, right? What do you notice about my result? I don't have any negatives. The result is never negative. Thus, all zeros are lower than 2. They're all below 2, right? So would it be smart to try 5? No. Honestly, guys, I don't use this very much. Not very much, okay? But that's one point that we can make there. All right, let's look at the lower bound, okay? If a is negative and you punch negative in and you come up with something like that, okay? Alternating signs. And 0 counts as an alternating sign. Then a is a lower bound. So I'm going to show that -3 is a lower bound for the polynomial. And all I have to do is 1, 0, -3, 2, and -5. Drop down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. What did I do wrong? Got 9, -6, 18, 20, -60. What did I do? Oh, there you go. Oh gosh. Wow. You know what's odd is that a lot of times if I make a mistake 1 hour, I'll make the same mistake then later on. I did not make that mistake in either of the classes. So, all right, there we go. I'm adding, huh? Oh, wow. Somebody get a new teacher in here. All right, so -18, and I got -16, 48, 43. I did it exactly like that in previous hours, trust me. I don't know what happened. Okay. What do you notice about the result? Signs alternate. Thus, all zeros are above -3 or greater than -3. So I'm going to pause and show you what I expect for your assignment today so that there's no confusion, because I often get this on the test, or on this assignment, okay? Here's what I get from people. People go and do 51 through 56, and they actually try to find all of the solutions. Don't do that. It's supposed to be very quick, 5 minutes for those problems, where all you do is just determine the number of positive and negative. Done. 57 through 60, you don't have to find all the zeros. Just show, like we did in our example, that you have an upper bound and a lower bound by doing the synthetic division process. That's it. Should be a quick 5 minutes. You got that? Then the very last two, you're going to do just like I do right now. Okay? So let's go back to that problem and finish it off. It says find all rational zeros of the polynomial and then any irrational, if there are any. Whenever appropriate, use the rational roots theorem, upper and lower bounds, DesCartes rule of signs, quadratic formula, and other factoring techniques. And if we're able, sketch a graph. Okay? So we can, the number of positive real. Anybody? One sign change, two sign changes. So 2 or 0. You always subtract by a factor of 2. No, you won't do that. So you would stop at 1 or 0. You never go below. Correct. Yes. So there'd be 4, 2, or 0. And we'll look at that next time. Okay. All right. The number of negative real, I first need to compute p of negative x. I get negative x cubed minus 3x squared plus 13x plus 15. How many sign changes? There is one sign change. I can't subtract 2 off of that. So what I know is that there's either 1 negative real and 0 positive, or there's 1 negative real, and 2 positive. So my total number of real will be either what? 3 or 1. It would be 1 and 2 or 1 and 0. Got that? The total number of real solution consists of the positive and the negative together. So I'd either have 2 and 1, which is 3, or 0 and 1, which is 1. Very good? Okay, well, let's look at our choices. What would we plug in for rational roots? Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So we could have positive or negative. We for sure have a negative one. It says we do. So what do we want to try? Let's do 1. 1 minus 3 is negative 2. Minus 13 is negative 15. Plus 15 is 0. Looks like 1 works. So therefore, what's a factor? X minus 1 is our factor. Let's divide that in. So factors to x minus 1 times x squared minus 2x minus 15. Does that factor? What is x minus 5, x plus 3? So what are my solutions? Good. I've got 5, 1, and negative 3. Here's part of why that's so cool. How many positive real solutions do I have? 2. We were able to know that from even before we started. How many negative real do I have? 1, for a total of 3 real. And all the choices match up with what works. So that's cool. Yeah. Could we sketch a graph? Yeah, way too easy. We're just gonna skip it. Okay, save you guys time. You guys are busy people. We do our last example. Heard that term a lot today. Study for Western, study for Western, study for Western. All right, great. Not till we get back from break. And it's a great test to do very well on. Okay, I expect the third quartile of this test, or the first quartile, to be around an 88%. That's my expectation. Yes. Yeah, yep, exactly. Okay, number of positive real. Good. So Jesse caught on that there's 1, 2, 3, and 4 total sign changes. In all the other hours, people miss that, but Jesse is exceptionally intelligent, and so now we get to Leiwa's question, which was, what if we have 4? Well, you subtract 2, and you subtract 2 more. Everybody good with that? Okay. If you have negative x, it's going to be a negative x to the 5th, minus 3x to the 4th, plus x cubed, plus 11x squared, plus 12x, plus 4. How many sign changes? 1. Therefore, how many total real solutions will there be? Yep. All right, very good. Choices. Olivia, you know I care about you. Okay, all right. Plus or minus 1, plus or minus 2, plus or minus 4. Although it's a fifth degree polynomial, which seems a pain in the butt, fortunately we only have 6 choices. You do understand that, obviously I do not tell you the exact questions you get on the test, but you know that if I give you a fifth, I'm not going to put a 96 on the end there. You realize I'm not going to do that to you, right? Or if I did, one would probably work. I mean, I'm not going to be cruel, you guys, about this process. What would you like to try? 1 minus 3 is negative 2, minus 1 is negative 4, plus 11 is, I missed somewhere. 1 minus 3 is negative 2, minus 1 is negative 3, plus 11 is 8, minus 12 is negative 4, plus 4 is 0. So 1 works. Will I have a great story for you later on. I have a great story for you later on. Okay, look at what I get. Do the signs alternate? No. Are they all positive? So we can't use the upper and lower bound piece at all to really help us out. If 1 worked once, could it work again? It could. 1 minus 2 is negative 1. Minus 3 is negative 4. Plus 8, 4, minus 4. Looks like 1 works again. Turns out I get x cubed minus x squared minus 4x plus 4 times that. Now, some people at this point would say, well, Mr. Gens, I would just like to use the rational roots theorem again. And that's fine. You can do that. I choose to factor at this point because I think factoring is quicker. Yep, this factors by grouping. What can I take out of this set? Yeah, so I get an x squared times x minus 4. No, not x minus 4. And then what do I factor out of the next part? A negative 4, and I get x. So if I take an x minus 1 out now, I'm left with x squared minus 4. Or x minus 1 times x minus 2 times x plus 2, right? And how many x minus 1s did we have total then? 3 of them. So it'd be x minus 1 quantity cubed times x minus 2 times x plus 2. So my solutions are what? Because so I have 1 here, and then I have 2 more from up there. So we had turned out that we had a total of 3 x minus 1s through the process. Now, again, as we look through and dissect, how many positive ones did we come up with? 4. Very good. How many negatives did we come up with? 1 for a total of 5. Are they all part of our choices? Could we graph it? We could. This is 5th degree. Is it positive or negative? So n going up, it'll start down. Single root at negative 2, but a triple root at 1. That's really quite an accurate graph. So. Math is beautiful. Cole does a mic drop. Thank you, Cole. So, 65 and 69 are the only two problems that you're going to do like we did at the end of our notes. Am I clear to everybody about the expectation for the first two sets of problems? I'm doing that because I feel bad when you try to find all the zeros and you're not supposed to. Because you end up wasting a lot of time. And as I said, I know how precious your time is to you.